Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, as I told you, well, I told you a little while ago, but for you, it would be yesterday, that I will go over logarithms and then we'll do some logarithmic properties and then solve logarithmic equations. And then after that, we would move to a new unit. I hope to finish like within next week so that you get time to review whatever you want before the Regents on the 18th. I already posted I think two or three back Regents exams with their solutions. Um, if you need to prepare for that, I wish you best of luck. So, what are logarithms? Well, logarithms are basically the inverse of exponents. So, for example, when I say there are like three pieces to a logarithm, first of all, we write log to the base b. I'll talk about that. So, log stands for logarithm. I have to have a base. I have to have a value. Let's say A or C or any letter and an answer. So this is the new abbreviation that we need to learn. Maybe I'll put the A between parentheses so you don't think it's B raised to the power of A or anything. It's just the logarithm to the base B of A equals C. This in plain, I was going to say in plain English, no, in plain algebra, in plain math, is equivalent to saying B, which is the base, raised to the right-hand side, which is the solution, equals A. So if I raise B to the C, I get A. For example, I can say, so for example, you see how easy it is. I can say log of 8 to the base 2. I'm asking, what power of 2 gives me 8? 3. So log, that's it. That means that's equivalent to saying 2 to the third equals 8. So it's just another way of representing a function. Okay? Remember, this is the exponent. 2 to the third equals 8. If I want to write it as the inverse, I say I take logarithms of both sides and I say log of 8 equals log of 2 to the third power, and we'll see how that translates into this in a second. Now the bases. The bases can be any number, fractional or integer. But if b equals 10, and that's how it started, when I was your age and we were solving very tough like multiplication or exponents, like fractional exponents problems, we didn't have calculators. So it was like almost impossible to do it. So we had logarithmic tables. And the table gives you the logarithms between 0 and 1. That's all. That's all what you need. And then if it's something, again, there are some rules to help you solve any multiplication or root problem. So we use the base of 10 because it's easy. Now, if you say, what is the log of 100? I say 2 because 10 squared is 100. Log of 1000 is 3. Log of 1/10 is -1. So all are powers of 10. If it's not a power of 10, then, well, you have to use the tables. Meaning, if you say 10 to the 1/2, which is the square root of 10, what is the square root of 10? I will get the log of 10 to the 1/2, okay? And that would be 1/2 of, you see, I'm going to show you the rule so you will understand what I'm saying. But if the base equals 10, we don't write it. We call that the common logarithm. We don't write it. So if you say log of 8. What is log of 8? I mean, how do I express 8 as a power of 10? 10 to what value gives me 8? Okay? So if I don't say anything, the power is 10. And we call it just log. if the base is e, you know e? Yeah, 2.718. We did e to the x before. We'll talk about it probably in pre-calc more and in calculus definitely. If b is e, we say ln, not log, natural log. Natural log. E is everywhere in nature, so natural log makes sense. Or Neperian logarithms, because the guy who started that, his name is Napier. So we say Neperian logarithm or natural logarithms now. No, nobody's saying Neperian, but that's like a historical background. Now, let's look at the rules. Remember we had rules for exponents when you say x to the a times x to the b equals x to the a plus b. We have similar rules. You should expect that since the logarithm is the reciprocal of the exponents. So if I say log to any base b of, I'm not going to use a, b, and c so we don't get confused. So I'm going to say log to the base b of x times y. It turns out that this equals log to the base b of x plus, oh, remember there we had x to the a times x to the b equals x to the a plus b. So it simplifies the multiplication into addition. And of course, if I have log to the base b of x over y, like we said before, division is the opposite of multiplication, and the opposite of addition is subtraction. So I get log to the base b of, and I say b instead of y. I'm sorry, I can't write and talk at the same time. So log to the base b of the numerator minus log to the base b of the denominator. And if I have log to the base b of x to the power of y. Remember what that was? Exponent becomes multiplier when the equals y times log to the base b of x. And if I have log to the base b of the root y, the yth root of x, I get 1 over y times the log to the base b of x. Log to any base of the number 1 equals 0. Why? Because any base to the power of 0 equals 1. You see, it's always the opposite. And of course, there we said log to the base b of 1 over x equals negative. Remember when we moved the exponent, we changed sign? Okay. Well, you don't have to put them between parentheses, but since I was started doing that, just so you can see the rules. Now there is a small piece, because if you take your calculator, okay? If you look at your calculator, you will see a button for log, meaning log to the base 10, and a button for ln, Neperian or natural logarithms to the base e. But I told you b can be any number. So what if I get, say, log to the base 5 of some numbers and they want me to calculate? I cannot use my calculator. That's a big problem. No, it's not. The nice thing is that if you have log to any base, of some number x, you can transform that using two different methods. The first method, you say log of the value you are trying to find over the log of the base. Meaning, I can say log, which is the logarithm to the base 10 of this number divided by the logarithm of base 10 of that. Or, of course, natural log of x over natural log of b. And that is my key to simplify tough bases, if I have a tough base. Okay, so these are the rules, very similar in, not similar, but they remind you of the rules of exponents. I may have it here since I was showing you these a little while ago. Or maybe I threw it away. No, I did not. So it should be somewhere here. Oh, where is the paper? Oh my God, I can't find it. I just wanted to show you the relationship between these rules. No, that's something else. That's the algebra. I don't know. I don't know where I placed it. Should be more careful. Oh, is it that? Yeah, yeah. You see, this was multiplication of the same base, and this is multiplication inside. They became out as addition, and the exponent became addition. Division became subtraction, subtraction. Power becomes multiplier. Power becomes multiple. Root became division, and root, I have the division, so log b of x divided by y. X to the 0 is 1, log of 1 is 0, reciprocal. X to the negative a, log b of x to the negative 1 is negative. So this negative, you can think of it something like that. But that's pretty much, the relationship between logarithms. So I'll keep this here, and we are going to solve few questions, and we'll see how we can expand and simplify uh, these types of logarithms. Natural log of x to the 6 times y cubed. Well, I have a product, I have exponents, so what do I do? The easiest way is to start by using this. We have two different things, x's and y's. So, and they are multiplied. So first of all, the first step you say it's natural log of x to the 6 plus natural log of y cubed. And then you come here and treat each one separately. So you get the 6 becomes a multiplier. So you're bringing it from the exponent as a multiplier. It becomes 6 natural log of x plus 3 natural log of y. That's it. If you want to check, you say, how do I check these are letters? Yeah, you can pick some numbers and see whether this natural log, what does it evaluate to? So for example, let's say I'm going to say example. I'm going to use x is 5 and y is whatever. I don't want to use, well, 10, doesn't matter. So this case would be the natural log of x to the 6, which is 5 to the 6th power, times 10 cube, which is 1000. What do I get? 16.56. Now let's look at that. 6 natural log of 5 plus 3 natural log of 10. What do, oh, oh, that's L. I thought I wrote 31. 3 natural log of 10. I get the same exact number. So I check my answer very easily by picking any two numbers, making sure that the numbers I pick are not negative. As we say natural log of -1, which is easy, by the way, okay? But it includes, it's an imaginary number, okay? The second one, again, I start by multiplication. So I break that into log to the base 8 of x plus log to the base 8 of y plus log to the base 8 of z cubed. You can do that, by the way, in your head once and for all, but I break it down into steps. We have the second step, log to the base 8 of x plus log to the base 8 of y plus 3 times log to the base 8 of z. Let's move to the next one. Oh my God. So I have a power and another power. Well, this power is applied to everything. So I can bring it down and say 4 times log to the base 9 of 3 cubed over 7. That's the first step. And then I have a division, right? X over y. So log of the top minus log of the bottom. So I have a 4, and then I open parentheses because I'm going to subtract two things, but both of them are multiplied by 4. Log to the base 9 of 3 cubed minus log to the base 9 of 7 cubed. The 3 will come as a multiplier. The 3 would come as a multiplier, so I can combine them and multiply that by 4. Or do you want me to do it on two steps? I don't have enough space, so I'm going to continue here and then write at the bottom. So we can write it in two steps by saying this guy is 3 log to the base 9 of 3 minus 3 log to the base 9 of 7. Then I factor out the 3, so I get 12 times log to the base 9 of 3 minus log to the base 9 of 7. And most people would stop here. But I always have to look at these two guys. Are they related? Yeah. 3 is the square root of 9, right? So I cannot write it as 12 log. I did it on multiple steps because I wanted to show you that, but we could have done it easier anyway. 3 is 9 square root of 9, or 9 to the 1/2 minus log to the base 9 of 7. So that becomes 12 times 1/2 log 9 of 9 minus log to the base 9 of 7. That's interesting. I haven't seen that before. What is log to the base x of x? Meaning, x to which power is x? It's 1. So this thing is 1. So 1/2 times 12 is 6. So I get 6 minus 12 log to the base 9 of 7. That's what I got. If I want to use a calculator, remember I told you, we don't have a base 9. So you have to do that as log of all of this divided by log of 9. So log of this thing divided by log of 9, and you see what you get, and then you check to see if you get the same answer here. This was a tough one because we have a division, and we have a power, and then we have another power, and then one of the numbers was a power of the base, and it's too much. Okay, but if you understand this, you are in good shape. Next one. First of all, I bring the 3 as a multiplier. So 3 log to the base 7 of x cubed over y. And then I say 3 times log to the base 7 of x cubed minus log to the base 7 of y. This 3 would come down, and maybe I can multiply it by the other 3 in one step to save time. So I get 9 log to the base 7 of x minus only 3 log to the base 7 of y. Notice this 3 came down, and then I distributed the 3. So I say 3 times 3 log 7 of x minus 3 times log to the base 7 of y. Number 5. Well, This is log to the base 8 of a to the 6 plus log to the base 8 of b to the 5th. So it equals 6 log to the base 8 of a plus 5 log to the base 8 of b. What about this one? 6 cube and 11 cube. Well, 6 cube and 11 cube is 66 cube, right? So I could say this is log to the base 4 of 66 cube. The 3 comes down as a multiplier, log to the base 4 of 66. Or you can say 3 log 4 of 6 plus 3 log 4 of 11. How about that? 2 log to the base 3 of u cubed over v. Remember, we say this is 2 log to the base 3 of u cubed minus log to the base 3 of v. The 3 comes down, and you distribute the 2, so you get 6 log to the base 3 of u minus 2 log to the base 3 of v. Do you see that? Natural log, this is 1/3. So this is like, okay, I'm going to write it above it so you can see it. Natural log of u times v times w raised to the power of 1/3. That's the meaning of cube root. So the 1/3 becomes a multiplier, natural log of u plus natural log of v plus natural log of w. Okay, we have a few more. Number 9. Wow, there are 17. Okay, number 9, log to the base 6 of that. So I break it down as log to the base 6 of 3 plus log to the base 6 of 2 plus log to the base 5 to the 6th power. The 6 comes down as a multiplier, and I end up with log to the base 6 of 3 plus log to the base 6 of 2 plus 6 log to the base 6 of 5. This one. Okay. Again, as notice that here I multiplied the 11 by the 6. I could have left them. Like in this case, you could leave them and say, because I will show you something interesting here. Log to the base 4 of 2 plus log to the base 4 of 11 plus log to the base 4 of 7 to the 4th. Do you see that 2 is square root of 4? Meaning I can write this as log to the base 4 of 4 to the 1/2. 4 and 11, they don't have anything in common, so log to the base 4 of 11. And this 4 becomes a multiplier plus 4 log to the base 4 of 7. And 4 and 7 I cannot simplify. The 1/2 comes down as a multiplier, and log 4 of 4 is 1. We did something similar to that before, right? So that is basically just 1/2. And you could have noticed that from the get-go. Remember here when we said the meaning of log to the base b of a equals c. So if I say log to the base 4 of 2, I'm asking you what power of 4 gives me 2? It's 1/2. But I did it on 2 steps to tell you that 2 is 4 to the 1/2, and then to tell you it really doesn't matter which rule you use as long as you use it correctly and in the right place. So that's 1/2 plus log to the base 4 of 11 plus 4 log to the base 4 of 7. Oh my God, what is that? Easy. I'm going to break it into two parts. So log to the base 6 of c to the fifth plus log to the base 6. I'm not going to write cube root of a. I would say a to the 1/3. So that becomes 5 log to the base 6 of c plus 1/3 log to the base 6 of a. Natural log. First of all, the 5 comes down as a multiplier. So 5 natural log of 5 square over 2 equals 5 times natural log of 5 square minus natural log of 2. The 2 comes as a multiplier, so it becomes 2 times 5 is 10 natural log of 5 minus, and I have 5 natural log of 2. Okay, let's see, since we have numbers, okay? What is natural log of, first of all, this is 25 over 2 to the fifth power, right? That's it. 5 square is 25. So instead of write 5 square and another power, you get 102.78. What is 10 natural log of 5 minus 5 natural log of 2? No, I did something wrong. Oh, because of the 5. No. Did I say natural log? We got the 5 multiplied by that, so 5 multiplied by those. Yeah. Is that 10 natural log of 5? Yeah, when I was taking the 10 and the 5, I said I can never, how do I get 102? Let's see if I did something wrong here. 25 over 2. Oh, that's a large number. 5 natural log of this, which is 5 natural log of the top minus natural log of the bottom. That's interesting. Oh. Natural log of 25 minus natural log of 2 times 5. Yeah, it's 12. Oh, yeah, I know what I did. It's correct. Natural log of 12 and a half to the power of 5. I I did in the beginning, I raised the whole thing to the power of 5. So you get the same result. I'm sorry, guys. Mhm. Okay, next. Hmm. Log to the base 5. First of all, the 6 becomes a multiplier, so you get 6 log to the base 5 of x cubed over y, which is, can you write it here again to save space because I don't want it to be very cramped. 6 log to the base 5 of x cubed minus log to the base 5 of y. The 3 becomes a multiplier, so you get 18 log to the base 5 of x minus 6. So I don't need to write it here. Log to the base 5 of x minus 6 log to the base 5 of y. Okay, number 40. Okay, this is interesting one. Log to the base 4 of 7 cube times cube root of 2. So first of all, I'll break it down into 2. Log to the base 4 of 7 cube plus log to the base 4, and I write this as 2 to the 1/3. Okay? Now, do you see the same relationship? Well, we can bring the 3 down. Forget about that. That's done. But you see 2 and 4. I can write this as 4 to the 1/2 to the 1/3. And we learned in exponent, when you have two exponents, you multiply them. So 4 to the 1/2 to the 1/3 is 1/2 times 1/3 is 1/6. So that becomes 3 log to the base 4 of 7 plus 1/6 times 1, which is log to the base 4 of 4, but this guy equals 1, right? 4 to what power is 4? 1. So you get, that's why when you have the base and one of these numbers are like, they have share power, like 2 and 4, 4 and 8, 2 and 32, anything that, or 3 and 9, or 3 and 27, or 9 and 27, you have to think, how do I write it like that? So you get 3 log to the base 4 of 7 plus 1/6. This one easy, right? So you're gonna break them into 3, and then there is a 2 multiplier. So just to save you time, it's log to the base 2 of u plus log to the base 2 of v plus 2 log to the base 2 of w. How about this? The 6 comes as a multiplier, so you get 6 log to the base 9 of 12 cubed times 7. And then you break it as 6 times log to the base 9 of 12 cubed minus log to the base 9 of 7. The 3 comes a multiplier, so you get 18 log to the base 9 of 12. Well, 9 and 12 are not like power of each other because this is 3 times 4, not. So if you want to do it, which, okay, I will tell you what I mean by that. Log to the base 9 of 7. You can 6. I don't want you to get confused like me and think this is 610 gram or something. 6 times log. So maybe we need to use a dot so we know. No, it's still 18.1. I hate this. Okay. I can stop here, and most likely you will get full credit. However, I can see that I can write the first term as 18 times log to the base 9 of 4 plus log to the base 9 of 3, right? Because 12 is 4 times 3. Minus 6 log, maybe I write it a little bit further. Now, this is 9 to the 1/2, right? And log 9 to the 1/2 is 1/2 log 9 to the 9, which is 1/2. And 1/2 times 9 is 18 is 9. So I have 9 plus 18 log to the base 9 of 4 minus 6 log to the base 9 of 7. And because I had the 12 had a 3 and the 9 is 3 square, I can break it down into 3 times 4 and do this. I hope this is not so confusing to you, but this is something we can do. I don't know if they will, if you leave it like that, you would lose. I don't think. I don't think this is good enough. But it would be great if you can see that you can even simplify it more. This one is log to the base 9 of c to the fifth plus log to the base 9 of a to the 1/3. So it's 5 log to the base 9 of c plus 1/3 log to the base 9 of a, and we are done. Okay, so that's basically it for today. Tomorrow we are going to look at solving logarithmic equations, and you have to be very careful there. We'll talk about it more tomorrow. And until then, I wish you all the best. If you have any comments or something is unclear, I made it hard on you, uh, just let me know, and I'll try to clarify it to you in answering your comment. Otherwise, I wish you all the best. Hope to see you soon. Thanks.